Okay, so the question is, find the equation of plane through the line of intersection of plane x plus y plus z is equal to 1 and 2x plus 3y plus 4z is equal to 5, which is perpendicular to the plane x minus y plus z is equal to 0. Second part is, also find the distance of the plane obtained above from origin. Okay, so let us first concentrate on the first part. So whenever we talk about line of intersection and a plane passing through the line of intersection of two given planes, a figure something like this should come to our mind, right? So if I say that this plane P1 is given to us and this plane P2 is given to us, so basically any plane, let us call it P, passing through the line of intersection where this becomes the line of intersection, any plane P passing through the line of intersection can be written as P1 plus lambda P2 is equal to 0. This is the basic concept of family of planes. Okay, but now we need to know the value of lambda to get the actual equation of P. So for that they have given you this data that the new plane should be perpendicular to this x minus y plus z equal to 0. Okay, so again before we proceed, let us again go back to the concept of equation of plane. So the general equation of plane is given by ax plus by plus cz plus d equal to 0. This is the general equation of plane. Now here we need to know one thing very well, that if this plane is represented by such a figure, then this normal vector, a vector which is perpendicular to the given plane, is given by ai cap plus bj cap plus ck cap. These I have taken directly from the coefficients of x, y and z. This is actually your normal vector, right? Okay, so if two planes are perpendicular, then their normals are also perpendicular. This is the second concept which we should also remember. If we know this much, then we can solve this particular question. Okay, so first of all, let us try to write the equation of P in terms of lambda itself, right? So what will happen? We will get equation something like this. We will get x plus y plus z minus 1. This is the left hand side portion of P1. We need to take everything on the left hand side. Okay, plus lambda times of 2x plus 3y plus 4z minus 5, and this quantity equal to 0 is our general equation of plane P, right? Let us further simplify this. Let us combine the coefficients of x, y and z. So that will give us 1 plus 2 lambda into x plus 1 plus 3 lambda into y plus 1 plus 4 lambda into z plus minus 1 minus 5 lambda equal to 0. This becomes our general equation of plane P. Now, using the same concept as we did in the standard case, I can now write a vector, a normal vector of this plane P. Let us call that n vector. So now n vector can be written as 1 plus 2 lambda I cap plus 1 plus 3 lambda j cap plus 1 plus 4 lambda k cap. Also, what we have to see that this plane should be perpendicular to this given plane, x minus y plus z is equal to 0. So using this same concept of normal, I can write the perpendicular or normal of the third plane. Let us call this P3. Okay, so the P3 plane will have normal vector n3, which will be given by I cap minus j cap plus k cap. When I have to do this, I just have to look at the coefficients of x, y and z in the equation, right? So now I have normal of both the planes. So if two planes are perpendicular, then their normals are also perpendicular. This is the concept that we need to use, which means that now n vector dot n3 vector should be equal to 0 if vectors are perpendicular. From here we can solve for lambda. So let us see what we get. When I take dot, I will get 1 plus 2 lambda into 1 plus 1 plus 3 lambda into minus 1 and plus 1 plus 4 lambda into 1. This should be equal to 0. So what do we get from here? We get 1 plus 2 lambda minus 1 minus 3 lambda plus 1 plus 4 lambda is equal to 0, which leaves us with 1 plus 3 lambda is equal to 0, which implies that lambda should be equal to minus 1 by 3. So lambda is equal to minus 1 by 3 when you will use in this standard equation. You will get your value of the plane, the equation of the plane, which can be seen to be like this. If I substitute lambda in our initial equation, we will get x by 3 minus z by 3 plus 2 by 3 is equal to 0, which can be further simplified down to x minus z plus 2 equal to 0. This is the required equation of plane after solution. So this completes our first part. But what is the second part? Also find the distance of plane obtained above from origin. Again, if we have to solve for the distance of any plane from a given point, let us call this point x1, y1, z1, and let us take again a general equation of plane, which is ax plus by plus cz plus d equal to 0. If this is the condition given to us, then the distance d is now given by modulus of ax1 plus by1 plus cz1 plus d upon under root of a square plus b square plus c square. This is the standard result which we can use directly. So in our case, the equation is x minus z plus 2 equal to 0, and the point is 0, 0, 0, because we are finding distance from origin. So this will give us value of d as modulus of, when we substitute x1, y1, z1 in the equation of plane. So I will substitute 0, 0, 0 in my equation, so I will be left with 2 in the numerator, and denominator is squares, under root of squares of the coefficients. So that will become under root of 1 square plus minus 1 square. That's it. So this distance comes out to be equal to under root 2.